Hi, this is Alex from devstories.eu. LlamaIndex, Context-Augmented LLM Applications, Episode 5 of 14. Nothing breaks a production pipeline faster than an LLM deciding to add, "Sure, here is your JSON," right before the actual data payload. You ask for machine-readable output, you get conversational filler, and your parser instantly crashes. Bridging the gap between unstructured natural language and reliable programmatic types is exactly what structured data extraction with Pydantic resolves. Take the scenario of parsing a messy email inbox filled with vendor messages, payment reminders, and unstructured receipts. Your system needs to extract structured invoice data from this text. If you rely on standard text generation, you get unpredictable results. One response might use camel case for keys, another might format dates differently, and prices often come back as strings with currency symbols attached. You end up writing endless string manipulation logic just to get a usable number out of the response. Instead of asking the model for JSON and hoping it complies, you define your exact requirements using a Pydantic BaseModel. You create a Python class called invoice. Inside this class, you declare the precise data types your application expects. You define the date as a string, the purchased items as a list of strings, and the total price strictly as a float. Here is the key insight. LlamaIndex takes your Pydantic class and automatically serializes it into a strict JSON schema. When you send the email text to the model, LlamaIndex attaches this schema and triggers the underlying model's structured output or function calling API. The schema acts as a hard boundary. The LLM is no longer generating free-form text. It is constrained to populate the fields of the JSON schema specifically with the types you demanded. You can also steer the model's reasoning directly inside your data structures. By attaching a field description to an attribute, you give the LLM targeted instructions. For the price attribute, you might add a field description stating to extract the final total cost, ignoring shipping fees. The LLM reads this description as part of the schema definition and applies that logic during the extraction phase. When the response comes back, LlamaIndex does not hand you a raw string or a generic dictionary. It processes the response through Pydantic and returns a fully instantiated invoice object. The data is already validated. Because the framework leverages native structured output features, the model knows in advance it must provide an actual float for the price, not a string representation of one. You can immediately access the invoice.price attribute in your code and perform math on it. There is no need to strip out conversational filler, remove dollar signs, or cast strings to numbers. The transition from natural language to application logic happens seamlessly at the extraction layer. By pushing your data schema directly into the extraction process, you force the LLM to adapt to your application code, rather than writing fragile application code to tolerate unpredictable LLM behavior. That's all for this one. Thanks for listening, and keep building.